What? start off. The next thing is so we call them problems or rain umbrella problems. Yeah, you can call them whatever you want. So what is the logic behind this? Again, here this is more simpler than what you have done so far. So the thing is, if the rain is falling and if you start moving, right, because of relative velocity, you think the rain is falling at a different angle. So that's the whole idea there, which I have already done. Like we did much more tougher ones than this. So this will look a little easy now. So when a person is moving, due to relative motion, he observes the rain is falling at a different angle and different speed. Okay. So what we do, we stop one of them, isn't it? And the best person to stop is always the man. So just stop the man and then you're done. You will see the question as usual. Just to give an example, listen to the examples. So let's say we have a man here who is going with speed u. And let's say the rain is falling vertically. How we do this thing? We stop the man. And how does that work? We take the man ka velocity, we subtract it from everyone. So the rain is falling like this. So we take u backward and we take u backward for the rain. Now the man will think, okay, I came to rest. But now he starts thinking this rain is coming with u to the left and v to the down. So he thinks the rain is falling at an angle. So if you take this angle to be alpha, then he will say tan alpha opposite side is u by v. So he thinks the rain is falling with this angle and the speed will be, because both the vectors are perpendicular, root over v square plus u square. So if he wants to protect himself from this rain, he needs to keep an umbrella not straight at an angle. And that's what's also called as a rain umbrella problem. So it will be like at what angle should the man hold the umbrella so that he will not get wet. You're getting this. So in reality, rain is falling straight. But because you started walking with you, now you start thinking rain is coming at an angle. Is the idea clear? Any doubts on this? That's it. That is the whole theme about rainman problems. So man sees the rain. At an angle alpha with vertical. You can, draw all the vectors and you can do all that. That's also fine. But the pictures, right, look more easy to see, nothing much. But is the idea clear, everyone? Clear? Let's see some questions on this. So let's say the man is going with a speed of 10 meters per second. The rain is falling at an angle of 30 degrees. So this is V rain. I will call it ground. So V rain ground is 10 meters per second. So the rain is also falling with 10 meters per second. At what angle with vertical does man see the rain? Every time man won't go in a line only. What if man is also walking at an incline? Let's say man is walking on an incline with 5 meters per second. The rain is also falling with 10 root 2 meter per second. So this is the velocity of the rain in the ground frame. So rain is actually falling with 10 root 2. This is the velocity of the man in the ground. The man is going like this. It's 5. Same question. At what angle does the man see with the vertical? Get them. It is just vectors. There's nothing there. Vector components. Stop the man, take his velocity, put it in reverse, and give it to the rain. Resolve I cap, J cap, get the angle. That's it. So this thing looks maybe a little kiddish with pictures and all, but it's comfortable and you can clearly see what is happening. People do it in different ways. People draw vectors and all. Nothing wrong. If you're comfortable with that, great. But for some reason, this thing, I feel like, yeah, it looks, oh, this is what is happening. I don't remember the answer, Karthik. Dekhna padega. Maybe I think it is 60. Get them both. I'll give 2 minutes and I'll show you both. They're really not that weird. So, but anyone still confused with the picture, please ask me. Okay, let's see the first one. So when you get questions, right, just we have to stop the man. So I will just with respect to man and resolve the velocity is also the rain also. So this is 10 sine 30 and this is 10 cos 30. That is how the rain was falling. So to stop the man, we need to put 10 backwards. I need to put 10 this way. Man will come to rest. Now, if you ask him, boss, what do you think about the rain? He will say, the rain is going backward. 10 sine 30 is 5. He says it's going is 15 backward. And 10 cos 30 is 5 root 3 downward. This is what he will see. You're asking angle with the vertical. So tan alpha, if you make a triangle, bring this 15 here, you'll get a triangle there. I hope that part was clear. So tan alpha is opposite side, 15 by 5 root 3. This is root 3. Alpha was 60 degrees. Yeah. Right, Karthik. So even though the rain was falling at 30, he thinks the rain is falling at 60. Now, monsoons have not started, but once it starts, you can observe this when you're going to your class, right, in a train or a car or bus. Like when the rain falls, observe that. The moment the vehicle moves, you'll see the rain literally bending. If you ever noticed it. What about the second part? I think second one answer is bad. I'm not sure, but let's see. My voice is lagging, yeah? No, no. Okay, you can rejoin. Maybe it's from your side, I guess. So what to do here? Same story, resolve them into components. So this would be 10, this would be 10. And for the man, it is 5, right? This is 37. So 5 cos 37 is 4, and this is 3. So we need to stop the man. So what to do? We'll put 4 backward and 3 downward. Means 4 backward and 3 downward. So when the man comes to rest, he will think this is going 10 minus 4 in the horizontal direction, 6. Vertically, it is 13. So he will think the rain is falling at that side with an angle alpha. Tan alpha is 6 by 13. Make sense? That's it. So if angle velocities are at angles, right? Resolve them I cap, j cap, and then subtract them. Are you all clear with this? Then with pictures, it looks easy and it is done. Now you want to do it with all that formulas and stuff, then this is how it goes. So velocity of rain, this is just vectors again with respect to man. So that is the meaning of this. This is velocity of rain with respect to man. Is simply velocity of rain with respect to ground minus velocity of man with respect to ground. So if you subtract man velocity from rain, you'll get the relative velocity. This is what we are doing basically. You're just subtracting the man velocity, and what you're saying is that. You can also write like this. So velocity of rain with respect to ground is velocity of rain with respect to man plus velocity of man with respect to ground. So some people like to do like this. What they do is vectors like this. So velocity of rain with respect to man and velocity of man with respect to ground. So if this is your VRM and if this was your velocity of man with respect to ground, then the resultant vector, right, from the remaining tail to the remaining head is that. So something of that sort. Yeah, it is just a picture there, so there's nothing there. So that's a vector way of writing it. Let's see something else. So frankly, all the questions are of this level. There's really not much you can think of. Stop the man and suddenly question becomes pretty straightforward. There's nothing else to do. They'll just keep playing. Okay, angle is that, angle is this and all. But let's see something little better in this. So let's say we have an inclined path like this. This angle is 30 degrees. This angle is 60 degrees. This is A, B, C, and D. So we have a man who is walking with a constant speed of 10 meter per second. He is always maintaining the speed. While climbing, while going horizontally, while coming vertically, he always goes with 10 meter per second. So on AB, when he is going from AB, he sees rain falling vertically. Remember, he sees rain falling vertically. It need not fall vertically. He thinks it is falling vertically. Basically, it's a relative velocity. On CD, he sees rain parallel to CD. And then if I have to draw this, this is what he is thinking. So when he is going this way, he is thinking the rain is also coming in this way only. It's coming and hitting your back. And while he's climbing, he thinks rain is falling vertically. Remember, these all are he thinks. At what angle does he see the rain on BC? Again with vertical. He sees the rain about BC. There is no information about the rain. Rain ka speed we don't know. Rain ka angle we don't know. Nothing we know. All we know is this thing. So when you go from A to B, he thinks the rain is falling vertically. Thinks, the word is important. He thinks, he sees, meaning in his frame. C to D, he thinks rain is going parallel to CD, means it is coming and hitting your back. Using this information, you need to figure out at what angle will he see the rain on PC. Let's get it. You got this, you got Rainman problems. There's nothing more on this. Compared to all that cats and dogs, the rain is easy. How do we even start? Meaning, first thing, right? We don't know anything about the rain, so I'll give you an idea. Start from like this. Assume the rain is having Vx and Vy. Start from there. Since you don't know the V and angle, let the rain have two components. Because agar Vx Vy pata hai, you know everything about the rain. Start like this. Let the rain fall at a velocity Vx and Vy. So if you can find a Vx and a Vy, my job is done. So try to figure out Vx and Vy. And I think you can find, right? So there are two data points, two variables. If I had to give you one more hint, start from CD. So you can take Vx, Vy, or you can do this also. Let the rain go with V at an angle theta. You can do that also. Whichever you like works. Both are the same thing. Take V and theta. I think that's better. So find V and theta, your job becomes easy. 120 nearest लोग इतना चांस नहीं आएगा. Okay, let's see. Let's see what happens on CD. So let rain fall with V and theta. Like this V, and I'm taking theta with the horizontal. You can take anything. Now look at CD. Something interesting you'll see there. When you are on CD, this angle is 60 degrees. The man is going along the incline. So this is the velocity of the man with respect to the ground. And you're also telling the velocity of rain with respect to the man is also parallel. And now just look at that vector thing. That means if you take velocity of rain with respect to man, which is velocity of rain with respect to ground, minus velocity of man with respect to ground. Now you're saying this vector is along CD, and you're saying this vector is also along CD. If sum of two vectors, if two parallel vectors are added, then the third vector will also be parallel, right? So if this is CD and that is CD, therefore VRG also must be along CD. That means the rain was actually falling along the CD direction. right? Therefore, the theta must be 60 degrees. These are making sense. So the rain also must be falling along CD. Are you getting it? If you take three vectors, right? So the resultant is along CD. This is along CD. So VRG must be along CD. Sum of two vectors or difference of two vectors. If it is giving a parallel vector, matlab all vectors are parallel. Any doubts on that one statement? So that was the main catch there. That was the information you need. Got it? So if this vector is also along CD, this angle was 60 degrees, alternate angles. So theta will be 60. Any doubts on this? All? Shreya, Manav, clear with this? Ananya, Ahana, Rohit, Soumya, Yukti, Dave. And then coming to AB. Now on AB, you're traveling with 10 meters per second. So if you resolve the components, this would be 10 cos 30, 10 sin 30. See, I draw a lot of pictures like. And what about the velocity? I don't know the speed, but I know the angle. This was 60. So this was V cos 60. You could have taken Vx, Vy. You'll still get it. So this is V sin 60. And now what you're planning to do? Stop AB, right? How will you do that? Subtract. Subtract 10 cos 30. Subtract 10 sin 30. Now when you do this person on the incline will think, okay, I came to rest. And he will think the rain is falling now with V cos 60. I have to remember, I have to subtract 10 cos 30. 10 sin 30. So this would be 10 cos 30. 10 sin 30 and V sin 60. And how does he see? He thinks rain is falling vertically. Therefore, the horizontal component must be 0. Matlab, these two must have got cancelled. If he thinks the rain is falling vertically, means there is no horizontal component. This component must have been 0. So V cos 60 is equal to 10 cos 30. So this will be V by 2 is equal to 10 root 3 by 2. There, we got everything. So the rain was actually falling at 10 root 3 at an angle 60 degrees. We found the velocity of the rain and the angle of the rain. All clear with this? So on CD gave you the angle, AB will give you the speed. Once you got all this, then you're done. So then we will say from B to C, our observer is going horizontally with 10. Your rain was falling at 10 root 3 at an angle of 60 degrees. How do? We stop the man. We put 10 backward. Now this becomes easy problem now. So man will think, okay, I came to rest. And he will say this velocity is 10 root 3 cos 60. This is 10. And this is 10 root 3 sin 60. So if you look at the resultant, this will be 10 minus 5 root 3 by 15. This is what he will see. Yeah, this is not a great answer. Tan alpha will be 10 minus 5 root 3 by 15. Divided by 5, and this will be 2 minus root 3 by 3. That's your answer, everyone. Main thing is this, like, you have to get the angle. You are walking in one direction. You think rain is also coming in that direction. How can the third vector be, right? If there are three vectors, sum of two vectors is the third vector, and two vectors are parallel. The third vector has to be parallel. I hope that logic is making sense. Sum of two parallel vectors is a parallel vector, or difference of two parallel vectors is a parallel vector. Once you got the angle, you'll get the speed. Once you got the speed, you will get everything. All clear with this? There again, if you see, question was not really tough, but it was a little different. It was not like, formula डाल दिया तो answer आ जाएगा. You have to think a bit. Clear with this? So make sure to go through this stuff. Rain Man, there's really not anything more they can ask. Matlab, anything they can ask will be like you can play around. Just stop the man, subtract the velocity, and you'll start seeing things. The next thing is riverboat. We have riverboat, riverman, aeroplane wind. All these belong to the same category of problems. So what was the idea here? First of all, let's talk about what a river does exactly. Let's say if you got a river, and when someone says the river is flowing with speed u, this is the top view. Cams on everyone. So when someone says u is the speed of the river, what is the meaning of this? If I take you and throw in the river, you will drift with you. That is the meaning of river. That's it. Anything that you throw in the water will go with you, right? If you put a piece of paper, it will go with you. So basically, river will give you an extra speed u. That's what. So when someone says river is going with you, think of like that. If an object is dropped in the river, it moves with you. On top of it, if you have your own speed, that's a different story. It'll add up basically. So it will gain additional velocity. There, that was the main theme there. And now we will say there is a man or there is a boat or there's an aeroplane, and they'll keep giving like this velocity of man in still water. Matlab, if it was a swimming pool or if it was a lake where water was not moving, he can swim with speed v. That is the meaning of still water. Matlab, if you just put him in a normal water and leave him, when he swims, he will go with v. Now, what happens if you have a river flowing and the man moving? Just to take an example, let's say we got a river. Let's say the river is going with 3 kilometers per hour. And let's say this guy is capable of going velocity of man in still water. This is still water, meaning it is not the water of the lake of the water, water of the lake. It is a different situation. If you take a swimming pool where there's no flow and if you keep it, you would have gone with that. The velocity of the man in a still water is 4 kilometers per hour. So this guy is capable of swimming with 4 in a still water. And let's say you start swimming straight. Now see what happens. So if you look at the man ka perspective, he himself is going with 4 straight, but the river is dragging him with 3 to the right. Making sense? So anyone on the ground, when they look at this person, they will think this guy is actually going at an angle like this. They think this is the resultant velocity. They don't see him going with 4 or 3. They think this person is going with 5 at an angle of 53 degrees. Is this making sense? If the river was not flowing, you would have gone straight. If you are not swimming, you would have gone to the right side. So if you swim and the river drags you, this is what would happen to you. All got the story of a riverboat problem. That's it. This is the main story behind riverboat. Whatever you do. But river will always give you extra u velocity. That's it. If you just add that, you have to add it, okay? You have to add that and you're done. Did you ever do this thing in an airport, right? You have these travelators, that escalator thing on a horizontal floor. If you stand on that and if you start walking, won't your speed add up? It is exactly like that. It's like a river is already moving. If you do nothing, you'll go with the river. If you do nothing, you'll go with the travelator. But if you decide to walk on the travelator, your speed actually adds up, isn't it? That is how you should think about a river ka problem. That's what a river does. River will give you that extra speed. All clear with this? Now in this, we have few cases. Case one, man swims along or opposite to the river. River is going with you. So let's say our man decides to go with the river. He's swimming with the river with V. Here he decides to swim opposite of the river V. So this V is the velocity of man in still water. If the water was at rest, you would have gone with V. So what will be the final velocity? So velocity of man in the ground frame, anyone who is on the ground and looking at him, they think he's going with V and the river is also dragging him, so V plus U I cap. In this scenario, velocity of man with respect to the ground, they will think he's going with minus V I cap plus U I cap. Make sense? If you go with the river, speed adds up. If you go opposite to the river, you slow down. As simple as that. Any doubts on this? That's it. So that's one case there. Uh, let's do this question. Give it a try. Read the question. Take 1 or 2 minutes and think what to do. Even if you don't know anything about this relative velocity and all that stuff, you can still do. Hmm. This is a question from Merido. This is the first question. So when I was in 11th standard, I took out this Erido. I saw this first question. I tried for 10 minutes and I closed that book and opened it after 1 year. So it took me a year to open the book again. The thing is, the language is a little weird because it's a Russian to English translation. So, and the symbols are also weird. So, yeah, maybe. And yeah, I was really not that strong. In the beginning, my physics was hopeless anyway. So, three, yeah, try. Everyone should try. Think how you can do. You can do with relative. You can do in the normal ground frame. You can draw a picture. You can do however you want. I'll show you normally with a picture without using any relative. First, understand the scenario. Forget about the question. What is happening? Try to put on picture and understand. That is actually more valuable than solving the question. Most people don't do that. They don't read the question. They don't understand the scenario. You can't visualize the scenario. Okay, boat ऐसा जा रहा है. Okay, ऐसा हो रहा है. Get the story. Take a minute. Yeah, maybe that's right, Anish. Right, Ahana. Try. Okay, let's see. First, let's see the story. Okay. So motorboat is going downstream, overcame a raft at point A. So there is a raft. What is a raft? Some wooden piece or something. Okay. So this was point A. So there was some wooden raft. The raft is simply a wooden piece. So what will the wooden piece do? It will just go with the speed of the river. It will just keep on going. It doesn't care. But now what you did, you came with a boat, right? And you started going down the stream. So you saw this plank at point A. Now, since you're going down the stream, your speed must be v plus u. You started going straight, and then you did this thing for, so this is time t is equal to 0. You did this thing for time t is equal to 1 hour or 60 minutes. And then what did you took a turn? So when you took a turn and you started coming back, you met this plank again. So you took a turn and you started coming back. This is where you met the plank. Right. So now while coming back, the speed is v minus u. Right. This is the turning point. This was the story. So you went down for 1 hour, then you took a turn, and then you came back, and then you met the plank. So the boat meets the plank. Hope the picture was clear. Great. Now, if you try to see the whole thing, so let's say like this thing, let the boat meet the raft. After time t, meaning from starting, it must have taken time t to travel. Now, let's find the distances. So what is this distance here? You're going with v plus u. So this distance here, I'll just call this thing as point B and point C. So A, B, so A to B, and let's say this is C. This will be v plus u into 1 hour. This will be v minus u into total time was t. So this is t minus 1 hour. And what was the boat doing all this time? The boat is just going non-stop with this u into t. Is this making sense? If the total time was t, the boat traveled for 1 hour down and it traveled t minus 1 upstream. Make sense? In this entire time, what was the boat raft doing? The log raft is simply going in a straight line. You can clearly see this is equal to this, the total distance. So v plus u into 1 hour must be equal to ut, the boat car distance, plus v minus u into t minus 1, the boat while it is coming back. So yeah, v plus u is equal to ut plus vt minus v minus ut plus u. U goes off, ut goes off. We get 2v is equal to vt, vv goes off, we get t is equal to 2 hours. So the total journey took 2 hours. Right, and it is also given in the question, they meet after 6 kilometers. So this thing was 6 kilometers. This was 6. So if ut was 6 and t was 2, u was 3 kilometers per hour. Is this making sense? Isn't it simply distance and all that formulas there? So there, you only need to know that the boat while going it is v plus u and while coming back it is v minus u. Once you know that, you can draw a picture and finish it off. Is this making sense? Now, another way to do this. Stop the river. Since the river is going at the constant speed, stop the river. Now, if it clicks, great. If it doesn't click, you should know your picture. If you stop the river, meaning someone is standing on the river, what will you think? You will think the raft is never moving, isn't it? Raft also will come to rest. Agreed? Because raft is also going with you, river is also going with you. So if you're standing on the river, you think the raft is at rest. And what will you think about the boat? You will think the boat is going with V only, because V is the velocity in still water, because the water came to rest. Meaning this boat traveled for 1 hour down. Now, because everything is at rest, to come back, it should take again 1 hour back, isn't it? You're getting the logic. If you bring the river to rest, the boat is going down with V for 1 hour. To come back again, it is coming back with V with respect to river. So that also should take 1 hour. So therefore, total journey is 2 hours. Are you getting the logic there? So with that, no need to draw and everything. It will be much faster, but it should click. ऐसा भी कर सकता हूँ. Are you getting what I did? If you stop the river, what will happen? If you stop the river, plank will not go anymore. The boat will simply go with V down and V back up. So going down and coming back, time must be remaining same. That's another way to handle this. That's much faster. So if I have to show, it looks like this. If you do with respect to river, stop the river. If you stop the river, the raft will be at rest. Because river is not moving, raft also will not move. The boat ka speed was V. So you'll go down for 1 hour. Because the river is at rest, you will also go back with V. So this must be 2 hours. So 1 hour to go down and 1 hour to come back. And then you know ut is equal to 6 and t is equal to 2 and u is equal to 3. Making sense? You see whichever it clicks. Meaning for me, though, this only clicks. I to literally draw a picture and I do it. That stopping the river thing, it doesn't click for me at least. But that's one way to do it. All clear with this? Any doubts on this, Rohit? Rohit, are you there? Tanmay, clear with this? Next thing. If someone is typing something to me, please type in the co-host thing. I can't see if you're typing to the wrong thing. Case 2. Minimum distance. You know, there is a Hrithik Roshan ka one movie came called Mohenjo-daro, which is a flop movie though. You have seen that. In that, Hrithik Roshan actually explains, riverboat problems. In the climax of the movie, right? There is a big flood and the whole city is getting flooded or something. Then they have a boat. Then he explains them. If you want to go here, then you have to go like this because the river is pushing and all that. It felt like, yeah, someone really prepared for JE exam. That guy must be the writer. They included that. Happens a lot. So look at this thing. Minimum distance. So we have a river which is flowing. So this is A, this is B. So AB is your shortest distance. You just want to cross the river with distance D. The river is going with you. The man can swim with V in still water. That is important. Meaning if the water was not flowing, you would have gone with V. Now the question is, if I want to reach B, how should I swim? So the first question comes. If I try to swim straight, what would happen? The river will push me to this side, so I'll go somewhere here, isn't it? So you cannot swim straight to go to the B, you should swim at an angle. So if the man swims at an angle V, so meaning you're looking somewhere else, but you're going somewhere else. So this is how it would look. So let man swim at an angle theta. So if you look at the man ka velocity, there is a V sine theta component dragging him to the left. The V cos theta is actually trying to cross him, but the river is pushing you to the right side. Be careful here. We don't subtract the river ka velocity. River ka speed will add up. So this is the vectors there. Now, how he wants to go? He wants to go straight, right? Therefore, the horizontal component must be 0. Since he wants to go along AB, the horizontal component u must be equal to v sine theta. There we get sine theta is equal to u by v. V must be greater than u, or else you can't cross the river. So if you want to cross the river, you should swim at this angle. So for example, agar u is 3 and v is 5, then it is 3 by 5, 37 degrees. That is the thing. And how much time will it take? Now, time taken to go from A to B. Now, remember, he's not using your full speed to cross the river. You're only going with v cos theta along AB. So AB is d and v cos theta. V and cos theta is 1 minus sine square theta. Bring that sine theta and substitute here. So time taken from A to B will be d by root over v square minus u square. This is the time taken to cross the river in minimum distance. So if he swims like this, he will travel least distance. But yeah, it might take more time. But the idea is clear, and this is the exact same thing what Hritiroshan explains. He says we want to go to B. So if we go straight, we will go like this. So if we take our boat and go here, the river will push us and bring us back to B. I don't think the guy who is beside understands. But yeah, hero, na? So they all listen to him. And I was laughing when I saw that scene. Now you will see a lot of things like this. There is this movie of Jai Ho, Salman Khan ka. In that, there is a thing like this: go and help one person and tell him to help three more person and tell them person to help three more person. ऐसा कुछ scene था. You know that? There's a movie like that. This is actually a nuclear chain reaction. If you take a uranium nucleus and hit it with a neutron, it emits three neutrons. These three neutrons will go and hit three more uranium neutrons, and that will give three more neutrons. This is called a nuclear chain reaction, which comes in a nuclear bomb. So someone took this thing and made a movie concept out of it. You help one person and then tell them to help three more person, and that person will tell them three more person, and so on. The whole city helps everyone, and everyone becomes a good person. There is some bullshit movie like that, but yeah, it works. Clear this? So just to give an idea here, so exactly how are you swimming and how are you going? If I had to draw a picture, so this is how it looks. This person is looking somewhere else. If you look at this person here, he is looking like this. You're getting? You're looking this way. This is how if you see that person, right, it looks pretty weird. They're looking somewhere else, but they're going in this direction. So he goes along AB. This was A and this was B. It's like you're looking to the left and walking straight. Right? But he's trying to swim in this direction. So his head will not be straight. His head will be like this. It's like you're looking at an angle and you're walking straight. He tries to swim this way. All clear with this? That's your case 2. So we have few more cases, case 3 and case 4, and some more variations there. So next class, I think the first half of the class, we will finish off this thing, and then we'll start off with graphs. So graphs are another important thing, which are not only for this chapter, going on for every chapter, graphs will keep coming a lot. So we will discuss a lot, like how to draw a graph, what are some common shapes and all that stuff. I think another 2 classes, we should be able to wrap it up. Okay, we have done almost 66 questions, and today's class was pretty heavy, especially the first 2 problems. Spend some time, take care of paper, resolve each and everything properly again. Okay, with that, we'll wrap up for the day. We have done almost 66 questions. You should be able to handle most of the material now. Graphs is the only thing, and then okay, with that, we'll wrap up for the day. On Wednesday, when we catch up, we'll continue from here. So any doubts, anything else, please stay back and ask, or feel free to leave.